Hello students, today we will be seeing the numerical based on your secondary settlement. Now we have already seen few lectures on settlement, primary settlement, secondary settlement. Now we will be discussing numericals based on it. So I will be preferring the textbook V.N.S. Murthy for Geotechnical Engineering, and let us see the numerical. This is the first example which is given in the book. So the example says during a consolidation test, a sample of fully saturated clay 3 centimeter thick is consolidated under a pressure increment of 200 kilonewton per meter square. When equilibrium is reached, the sample thickness is reduced to 2.60 centimeter, and the pressure is then removed and the sample is allowed to expand and absorb water. The final thickness is observed as 2.8 centimeter and the final moisture content is determined as 24.9%. Then they are saying if the specific gravity of soil solid is 2.7, then find the void ratio of the sample before and after consolidation. Okay, so they have given the figure likewise. Now, the second diagram they have given with the results. Now, let us just directly move towards the solution. Now, in the textbook, they have not given the given datas, but when you are writing for your exams or when you are practicing your numericals, you can write down all the given datas in a proper manner, and then you can write down what and all is required to find out. Now, here they have asked the void ratio of the sample. Now, you can refer the page number in V.N.S. Murthy Geotechnical Engineering. They have given the formula for void ratio of sample, which is delta E is equal to 1 plus E divided by H into delta H. Here, your delta E is nothing but the change in void ratio under the load pressure. Small h is nothing but the initial height of the sample, and small e is initial void ratio of the sample, and delta H will be the compression of sample under the load. Now this is the formula which we will be requiring, and for that what and all is required over here we will be determining. So the very first thing we will be determining the EF. EF is nothing but the final void ratio. So for that we have the formula Ws is equal to Vs into Gs into gamma W, which is given in the page number 214 in V.N.S. Murthy Geotechnical Engineering. If you want to refer the textbook, you can refer this. There they have given Ws. Ws is nothing but the weight of solids. Vs is nothing but the volume of solid, and Gs is the specific gravity of solid, and gamma W is nothing but the unit weight of water. Now let us just put all the values in this formula and we will be getting our Vs is nothing but your volume of solid, so we are considering it as a unit weight, so Vs is nothing but 1, and specific gravity of solid is given as 2.70, so we will be putting the value 2.70, and again the unit weight of water is 1. So after calculating the weight of solids, we will be getting 2.70 grams. Now next thing we have, like they have given in the question, which is the ratio. Okay, so ratio of weight of water divided by weight of solid is given as 24.9%, so you can consider it as 0.249, or else we can write it W, which is weight of water, is equal to 0.249 into we have calculated already the Ws, which is your weight of solids, so it will be 2.7. Once you calculate it, you will be getting the value as 0.672 grams. So the weight of water is nothing but 0.672 grams. Now we can consider the initial void ratio as EF, which is equal to volume of water, which is 0.672. We just calculated. Now our second step is to calculate the change in thickness. Now changes in thickness is nothing but delta H. So initially the height was 2.8, and then once the load was applied, the thickness has reduced to 2.60. So you can calculate the height difference, which is 0.2 centimeter. Now you can put all the values in the void ratio of samples formula, which is nothing but delta E is equal to 1 plus E divided by H into delta H. So here we have small e as 0.672, we just calculated. Height as delta H as 0.20, and your initial height is given as 2.80. Now once you calculate, you will be getting delta E as 0.119. Okay, so void ratio after the consolidation we can calculate as EF minus delta E. So we have just calculated delta E. You can put the values and get the void ratio after the consolidation, which is nothing but 0.553. Okay, now the last step is to find out the change in void ratio from the commencement of the end of consolidation. Now you have to calculate overall जो भी final values हैं that you can calculate. So again we will be using the same formula for void ratio sample, which is delta E is equal to 1 plus 0.553, which we just calculated after the consolidation, whatever void ratio has been given, and divided by 2.6 because you have applied the load and the thickness has been reduced, as or you can say the void ratio has been reduced, and multiplied by 3 minus 2.6, which is nothing but the change in your height. Now you can calculate and you'll be getting the final value as 0.239. Now the void ratio at start of consolidation will be 0.553 plus the previously which we have calculated is 0.239, and you'll be adding totally. So we'll get the total void ratio as 0.792. So this is a very basic numerical which we can solve. Okay, so I hope this numerical has been clear to you all. And in the final diagram, you can put the total height as 0.28 centimeter, volume of water as 0.672 centimeter cube, and WS is nothing but the weight of solid as 2.7 grams. Okay, if you have any doubts, you can put down in the comment section below. Okay, thank you for watching, and you can subscribe the channel. Thank you.